For this video, we're going to be discussing adding, subtracting, and multiplying radicals. So, radicals can be added, subtracted, multiplied, or divided. We'll be discussing dividing in a different video. And we can perform these operations just like we would with numbers. When we are adding or subtracting, we can only add or subtract like radicals. Those are the only things that can be combined. Like radicals are numbers where everything but the leading coefficient is the same. So let's take a look at some examples of what that means. So here are some things that are like radicals. Okay, 4x times the square root of 3xy and 7x times the square root of 3xy are the same, or are like radicals, because if we look at everything except for the leading coefficient, okay, if I ignore my leading coefficient, everything else is exactly the same. Same thing down here. Here's my leading coefficient, 8. This is a squared b times the cube root of b. And here this is negative 8 times a squared b times the cube root of b. So because everything but my leading coefficient are the same, then these are like radicals. Now over here, these are some numbers that are not like radicals. Okay, so if I look, this is 8m times the square root of 2m squared and 4m times the square root of 2m to the fourth. The problem here, what makes these not like radicals, is this squared in this fourth power. Because these two are not the same, these are not like radicals. All right, similarly, if I look down here, I've got 6a to the fourth b times the fifth root of ab, and 7a squared b times the fifth root of ab. Because this is a fourth, and this is squared, then these are not like radicals because something other than the leading coefficient is different. Right? And so that's our problem. Okay? We have to have the same leading coefficient in order for them to be like radicals. So let's talk about how to add and subtract. Okay? Your first step is to simplify each radical, and then you just combine the like radicals. So let's take a look at an example here. I want to simplify negative square root of 2 minus the square root of 54 minus square root of 24. So if I work my way through this, negative square root of 2, well, negative square root of 2, square root of 2 is already as simplified as it's going to get, so I don't really have to do anything else. Square root of 54, I need to split up a little. So square root of 54, 54 breaks down into 9 times 6. 9 is our perfect square, and 6 is not a perfect square. Square root of 24 is 4 times 6. Okay, 4 being our perfect square, and square root of 6 being our non-perfect square. So if I work these out, the square root of 9 is 3, and the square root of 4 is 2. So I've got, well, that's weird. Here we go. So I've got negative 2 minus 3 square root of 6 minus 2 square root of 6. So I want to look at these, and I want to see what are my like radicals. Well, this is square root of 2, this is square root of 6, this is square root of 6. So these two are my like radicals. So I can combine those two to get negative 3 minus 2 is negative 5. So these two combine to get me negative 5 square root of 6. And this negative square root of 2, that just stays by itself. It can't combine these two with these two because they're not like terms. They're not like radicals. So my answer is negative square root of 2 minus 5 square root of 6. Now let's take a look at multiplying radicals. So to multiply radicals, we're going to multiply this outside by outside and inside by inside. So anything that's outside the radical in one expression is going to get multiplied by the stuff outside the radical in another expression. Stuff inside the radicals will be multiplied by the stuff inside. Then we're just going to simplify the resulting radical. So let's see what that looks like. So here I want to simplify the square root of 6n cubed times 3 times the square root of 8n cubed. All right, so if we think about this, we want to go outside times outside, inside times inside. This one is just 1 times on the outside, so 1 times 3 is just 3. Inside, 6 times 8 is 48, and n to the third times n to the third is n to the sixth. So this becomes 3 times 48 n to the sixth. Now, I've got to simplify my radical inside, so I want to split this up. All right, so if I split it up, 48, my biggest perfect square is 16, and its pair is 3, so 48 is 16 times 3. N to the 6th, 6 is a multiple of 2, so it's already a perfect square. So if I just follow my rules for simplifying, my perfect squares, which are 16, pen works, 16 and n to the 6th, those go in one radical. And my non-perfect square, that should be a 3, not a 2, goes in the other radical. All right, so if I work this out now, the square root of 16 is 4, and square root of n to the 6th should be n cubed, so 6 divided by 2 is 3. There should still be a 3. So now if I work this out all the way, I gotta finish this. 3 times 4 is 12. So this becomes 12n cubed, and I just really messed this up. This should be a 3. So my final answer is 12 n to the third power times the square root of 3. So we just multiply outside times outside, inside times inside, and simplify our radical. So after watching this video, you should now know how to add, subtract, and multiply radicals.